Hello, and welcome to this module on session hijacking. Let's see what we'll be covering in this video. We'll kick off with what is session hijacking, and follow that with what causes a session hijacking vulnerability. Then we'll look at how are sessions hijacked, the actual methodology. Then we'll look at session hijacking techniques, and then finally we'll close off with countermeasures. Let's get started. So what is session hijacking? Well, let's look at hijacking first. So hijacking is a type of network security attack in which the attacker takes control of a communication, just as an airplane hijack would take control of a flight between two entities and masquerades as one of them. So if we look at this picture here from OWASP, you'll see you have the blue PC, which is the normal visitor or the victim, and a web server that victim is talking to. So what we do in a hijacking attack is the attacker actually steals that session or that credential and then impersonates that user on the server. So in other words, whatever rights that server had for that session, the attacker now has it. So if we look then at the definition of session hijacking is sometimes also known as cookie hijacking, and it's the exploitation of a valid computer session, that blue line over there, to gain unauthorized access to information or services in a computer system. So just like the little picture shows, as soon as that session is hijacked by this attacking PC or this attacking individual, that individual will have exactly the same rights because the web server truly believes that it's talking to the exact same person because of the authentication token that is being used by the attacker. Great. Let's move on to what causes a session hijacking vulnerability. So what causes a session hijacking vulnerability? Well, there are a few things and a few methodologies and a few techniques, or bad techniques in this instance, that developers use when they write their web applications. And session hijacking could be a network session or any other session, but primarily it's a web session, and that's what we're going to be concentrating on. So let's look at the session hijacking vulnerability causes. The first one is no session timeouts. So in a web application, when you actually log into a website and get authenticated, it creates what's called a session state. Now, the session state exists because HTTP as a protocol doesn't understand state. In other words, every connection you make to a web server is a brand new connection. So the way HTTP or web developers get around that limitation is by creating what's called a cookie that is then installed as a file on your local file system, so that every time you connect back to the actual website, it will see it as a return. So it will remember what you are and what rights you have. And when you create those cookies, you can set the expiration or the timeout on those cookies. So for example, if you log into webmail daily, you'll notice you won't have to put in your password all the time, and that's because the session state is still active. In other words, the expiration date of that cookie might be a week, a month even sometimes. But for truly secure applications like banking applications, the session state should end as soon as there is a timeout. In other words, they set a 5 or 10 minute timeout, and if you haven't actually re-engaged that session within that time limit, it should lock you out. If there are no session timeouts, session hijacking becomes really a lot simpler. Insecure session handling. This is also web development bad practice, not best practice. And it pretty much talks to how cookies are transmitted over the wire and how they are stored. So an example would be encryption. So you'd want to encrypt and hash your cookie if for specifically a secure application to ensure that the session handling is done in a secure fashion. Weak algorithms and session ID generators. So there have been a number of cases where, let me give you an example. So let's just say you log into a site where you go look at invoices, and you can see your session ID is 0001. Now, pretty much you would be able to guess that the next session ID, which might not be you, might be 0002. So that, and if you put it in, you'll have access to whatever system settings that individual or that session had. And the problem with session IDs is they need to be very, very long, and they need to be very, very random. If they are easily guessable, then it actually makes session hijacking very, very easy, because you actually won't need to do any of the technical attack. You can literally just guess the session ID and take over that session. And then finally, clear text, which talks to the insecure session handling. And once again, that is a failure of encryption. So as with our sniffing attack, because session hijacking's got a lot of sniffing involved, always encrypt your data if you don't want your session to be hijacked. Great. Let's go see the actual methodology on how sessions are hijacked now. Okay, let's see how sessions are hijacked. Great. So we'll start with traffic sniffing. As with the module on sniffing, we need to perform a man-in-the-middle attack and basically be able to sniff network packets, because we are looking for unencrypted clear text cookies so that we can steal the session. We then capture the session. In other words, we capture the actual packet that has the cookie inside with the session ID. We desync the victim if we want it to be an active attack. In other words, we knock the victim offline and take over his session. But you could also very easily have a passive session where both of you could be logged on at exactly the same time. However, obviously, if you're clicking on links and doing things, it will become quite apparent to the victim that something is up. Then we impersonate the victim to the actual website. So in other words, we actually type in a URL or and actually take over that session, and then your hijack is achieved. Great. Let's look at some session hijacking techniques next. Okay, so as I said in the session hijacking vulnerability slide, you could always calculate or guess the session ID if it's a very poor algorithm or if they're just using consecutive numbers. You could steal the session, which is what we will be doing in the demo. In other words, sniff the traffic, look for the packet that's got the unencrypted cookie in, steal the cookie, and then impersonate the user on the actual web application. You could brute force it. In other words, you could guess the session ID. That's obviously in a case where the session state would be set to a very, very long time, because brute forcing does take time. And if the session timeout is a couple of minutes, you have a very small window of opportunity to actually perform a brute force on a session ID. And then finally, you could also forge the TCP packets. And that's just an example I've put into the slide for actually hijacking network level sessions. In other words, sessions on the TCP IP stack. But like I said before, we generally concentrate on web applications when we talk about session hijacking. Let's see what countermeasures exist. Okay, so encryption. As always, very, very important to encrypt your traffic. It makes sniffing cookies and looking at clear text packets very, very difficult indeed if they are encrypted. And that is always something that you should do to protect your networks and your applications. You could use very large random number generators, and these generally come pre-built into all the development frameworks now. .NET's got massive random number generators, as does the Java applications, Python, Ruby. They all have really, really good random number generators, and these should be used to create your session IDs. Have a very short session state. In other words, the cookie is only valid for a very short period of time. Nothing ever more than a day. I don't see why you would want to have the user not log in on a daily basis. Yes, it makes it more convenient, but it also makes it very insecure. Principle of least privilege always applies. Security best practice. In other words, every user should only be given access to what they really need. So in the event that the session is hijacked and it's just a normal user, the actual attacker won't have access to the entire application. They'll only have access to what that user has access to. Then two-factor authentication is always a great technique to prevent some sort of session hijack, because there would be a second form of authentication, a token or a email or something that gets sent where a second form of authentication is needed to actually log into the system. So if someone steals the session and is prompted for a two-factor authentication, they won't be able to access that unless they have access to your phone, your RSA ID, or whatever it is that you're using for two-factor authentication. And then finally, session timeouts. If a session hasn't been accessed for an X number of time, and it talks the same as short session state, then the session should automatically end. And that brings us to the end on this theoretical video on session hijacking. Thank you very much for watching.